Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on December 9th, 2025, about 5 days ago. It introduces Luxical, a tiny lexical dense embedding model that mimics transformer text embeddings while running about 3 times to about 100 times faster, yet still matches the quality of strong neural baselines for large-scale text organization. The paper is titled Luxical, High-Speed Lexical Dense Text Embeddings. And as we will see later, the approach could seriously reshape how people do web-scale data filtering and retrieval on everyday hardware. Alright, the previous segment introduced the big motivation. Figure 1 now sketches how Luxical actually turns raw text into a fast embedding. The left side shows lexical featurization, where text becomes tokens, then a bag of words, then a sparse TF-IDF vector that reflects which phrases are distinctive. The center linear projection maps this sparse vector into a shorter dense vector. The right side illustrates a tiny feed-forward network with ReLU and L2 normalization, which finally produces the dense embedding vector used for retrieval and clustering. Figure 2 now explains how the tiny model actually learns from a powerful transformer teacher. The input text goes through both teacher and student embedders, producing 2 sets of vectors that appear as blue X rows and orange Y rows. These vectors form student and teacher gram matrices, which are tables of all pairwise similarities inside the batch. AKL divergence loss then forces the student similarity table to match the teacher's table, so the cheap model copies the teacher's geometric structure without recreating its full architecture. Well, Figure 3 moves from training to raw speed, showing end-to-end embedding throughput on different hardware. The main bar chart compares documents per second for Luxical 1 on a CPU against Mini LM and QN baselines. Luxical 1 on a single Apple M4 Max CPU reaches about 6,800 documents per second, roughly 23 MB per second, which is about 97 times the QN GPU baseline. Mini LM on a GPU hits about 2,400 documents per second, while its CPU version and the QN GPU model lag far behind. The legend on the right highlights that Luxical's numbers come purely from CPU execution without any GPU help. Alright, Figure 4 shifts to quality, showing how often each model fails to match 2 halves of the same document as the retrieval window grows. The full chart plots error rate on the vertical axis versus how many documents are retrieved out of about 100,000 on the horizontal axis. At very small windows, transformer teachers like Arctic and Quen do best, with Luxical 1 slightly worse. As the window widens to tens or hundreds of documents, Luxical 1 nearly overlaps the teachers and clearly beats Mini LM. This pattern means the fast lexical dense model preserves the coarse similarity structure that matters for large-scale retrieval, even if strict top 1 ranking is a bit weaker. So, Figure 5 ties speed to actual language model quality across several benchmarks. The top row of panels shows that the Luxical 1 score processes documents as fast as, or faster than, the fast text-based and FineWeb ADU scorers across all token budgets. The bottom row then shows downstream accuracy, where models trained on Luxical curated data closely track the best baselines and stay far above the no-filter random sampling curve. This pattern means Luxical delivers near state-of-the-art data quality while keeping the filtering pipeline extremely fast. So, the previous figure linked Luxical speed to downstream accuracy, and this bar chart drills into raw throughput for end-to-end scoring pipelines. The full plot compares documents per second and MB/bytes per second for 3 setups. The top bar shows Luxical embedding plus MLP classification on an M4 Max CPU handling about 6,800 documents per second, roughly 14 times the FineWeb Edu score. The middle bar shows a regex plus fast text pipeline, which is slightly slower at about 5,600 documents per second. The small bottom bar marks the FineWeb Edu score on a powerful A10 GGPU, which only reaches about 480 documents per second. Luxical shows that a tiny lexical dense model, trained to mimic transformer geometry, can deliver transformer-like retrieval and data curation quality while running tens of times faster on plain CPUs. That shift makes web-scale filtering, clustering, and deduplication far more accessible. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.